Hello students, myself Shashikumar SK, Department of Physics, IDSG College, Chikmagalur. In this class, let us discuss about problems on rectifier. This was already did in the offline classes, but many of the students were absent in that class. Therefore, I am doing a video again for the benefits of the students. Now, the first problem is a half-wave rectifier is used to supply 30 volt DC to a resistance of 600 ohm. The diode has forward resistance of 25 ohm. Find the maximum value of AC voltage required at the input, which means already half-wave rectifier 30 volt DC supply ಮಾಡ್ತಾ ಇದೆ. ಯಾವ ಒಂದು ರೆಸಿಸ್ಟೆನ್ಸಿಗೆ 600 ಓಮ್ ರೆಸಿಸ್ಟೆನ್ಸಿಗೆ. ಆ ಡಯೋಡ್ನ ಫಾರ್ವರ್ಡ್ ಬಯಾಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್ 25 ಓಮ್ ಇದೆ. ನಾವು ಏನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ಬೇಕು? ವಿ ಮಸ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಎ ಸಿ ವೋಲ್ಟೇಜ್ ವಿಚ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಗಿವನ್ ಟು ದ್ಯಾಟ್ half wave rectifier to obtain a 30 volt DC. And given datas are VDC is equals to 30 volt, RL is 600 and RF is 25. Average value of a load current is given by, ನಮಗೆ ಅವರು ಡೈರೆಕ್ಟಾಗಿ ಎ ಸಿ ವೋಲ್ಟೇಜ್ ಕೇಳಿದ್ದಾರೆ. ಎ ಸಿ ವೋಲ್ಟೇಜ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು ಅಂತಂದರೆ ಫಸ್ಟು ಡಿ ಸಿ ವೋಲ್ಟೇಜ್ ಡಿ ಸಿ ಕರೆಂಟನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ಬೇಕು. ಬಿಕಾಸ್ ಡಿ ಸಿ ವೋಲ್ಟೇಜ್ ಎಷ್ಟಿದೆ ಅಂತ ಗೊತ್ತಿದೆ. ಆ್ಯಾವ್ರೇಜ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಅ ಡಿ ಸಿ ಲೋಡ್ ಕರೆಂಟ್ ಈಸ್ ಗಿವನ್ ಬೈ ಐ ಡಿ ಸಿ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ವಿ ಡಿ ಸಿ ಬೈ ಆರ್ ಎಲ್ ಆ್ಯಸ್ ಲೈಕ್ ಅ ಓಮ್ಸ್ ಲಾ. ಐ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ವಿ ಬೈ ಆರ್. ಅದೇ ಥರ ಐ ಡಿ ಸಿ ಈಸ್ ಈಕ್ವಲ್ಸ್ ಟು ವಿ ಡಿ ಸಿ ಬೈ ಆರ್ ಎಲ್. ದ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ ವಿ ಡಿ ಸಿ ಆ್ಯಂಡ್ ಆರ್ ಎಲ್ ಈಸ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್. After simplification, I am going to obtain 0.05 ampere. Next, we must require to calculate the maximum value of load current, and the relationship between load current and DC current is given by Im, that is I maximum is equals to pi into I DC. ಸೊ ಆಲ್ರೆಡಿ ಐ ಡಿ ಸಿ ವ್ಯಾಲ್ಯೂನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. ಸೊ ಆ ವ್ಯಾಲ್ಯೂನ ಪೈ ಜೊತೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ನಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಲೋಡ್ ಕರೆಂಟ್ ಬರುತ್ತೆ. ಹೆನ್ಸ್ ಆಫ್ಟರ್ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಒಬ್ಟೈನ್ 0.157 ಆಂಪಿಯರ್. Now a maximum AC voltage supplied for that half wave rectifier is given by V input is equals to I maximum square into RF plus RL. This standard formula already discussed ಮಾಡಿದ್ದೀವಿ. Hence input voltage is given by IM square into RF plus RL. Values of IM and RF and RL substitute ಮಾಡಿ simplify ಮಾಡಿದ್ರೆ we are going to obtain the value as 15.4 volt. Next question, that is a half wave rectifier is used to supply 100 volt DC to a load of 800 ohm. The diode has resistance of 20 ohm. Find AC voltage and efficiency of that half wave rectifier. ಅಂತಂದರೆ ಆಲ್ರೆಡಿ ಎಗೈನ್ ಇದರಲ್ಲೂ ಕೂಡ ಎ ಸಿ ವೋಲ್ಟೇಜು ಮತ್ತು ಎಫಿಷಿಯನ್ಸಿನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮಲ್ಲಿ ಜಸ್ಟ್ ಎ ಸಿ ವೋಲ್ಟೇಜ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಿ. ಇಲ್ಲಿ ವಿತ್ ಅಡಿಷನ್ ಎಫಿಷಿಯನ್ಸಿ ಆಫ್ ದಟ್ ಹಾಫ್ ವೇವ್ ರೆಕ್ಟಿಫೈಯರ್ನು ಕೂಡ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ಬೇಕು. ದೇರ್ ಫೋರ್ ಒಂದು ಸ್ವಲ್ಪ ಡಿಫ್ರೆಂಟ್ ಮೆಥಡಲ್ಲಿ ಟ್ರೈ ಮಾಡೋಣ. ವಿ ಡಿ ಸಿ ಈಸ್ 100 ವೋಲ್ಟ್, ಆರ್ ಎಲ್ ಈಸ್ 800 ಓಮ್, ಆರ್ ಎಫ್ ಈಸ್ 20 ಓಮ್. ಮ್ಯಾಕ್ಸಿಮಮ್ ವೋಲ್ಟೇಜ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ calculated. For that, VDC is equals to IDC into RL as per the Ohm's law, but IDC is given by 1 by pi into VM by RF plus RL into RL. ಅಂತಂದರೆ IDCಯ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ವ್ಯಾಲ್ಯೂ ಈಸ್ ಗಿವನ್ ಬೈ 1 by pi into VM divided by RF plus RL. ಸೊ ಅದನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿಕೊಂಡ್ರೆ ನಮಗೆ ವಿ ಎಮ್ ಮ್ಯಾಕ್ಸಿಮಮ್ current is going to be obtained as Vm is equal, so maximum voltage is given by Vm is equals to 100 into pi into 820, that is addition of Rf plus RL, that becomes 800 plus 20, 820 divided by RL. Simplify ಮಾಡಿದ್ರೆ ನಮಗೆ ಈ ಒಂದು ಫಾರ್ಮಲ್ ಸಿಕ್ಕುತ್ತೆ. ಫೈನಲಿ Vm is given by 321.85 volt. Maximum voltage is calculated as Vm is equals to 321.85 volt, and the second part is efficiency. Efficiency is given by eta is equals to 0.406 divided by Rf by RL plus 1. That is the formula for efficiency, and we know the value of Rf and RL. So substitute ಮಾಡಿ simplify ಮಾಡಿದ್ರೆ we are going to obtain efficiency as 0.396, but usually efficiency are going to be expressed in terms of percentage, hence it is going to be taken in terms of percentage as 39.6%. One of the important problem which has been solved. Next question is on the basis of full wave rectifier. A full wave rectifier has a load of 1 kilo ohm. The AC voltage to the diodes is 200 volt. If diode resistance is neglected, calculate average DC voltage, average DC current and ripple voltage, which means ಇಲ್ಲಿ ನಿಮಗೆ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ. ಬಿಕಾಸ್ ಫುಲ್ ವೇವ್ ರೆಕ್ಟಿಫೈಯರ್ ಇನ್ಕ್ಲೂಡ್ಸ್ ಅ ಸ್ಟಂಟ್ ಟ್ಯಾಪ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ and it is designated as 200 volt, means the transformer is going to be supply a 200 volt. Therefore RL 1 kilo ohm ಕೊಟ್ಟಿದ್ದಾರೆ. voltage supply input supply is 200 volt. Average DC voltage is given by VDC is equals to 2 times Vm divided by pi, and they had given transformer input voltage, therefore RMS value ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. ಸೊ Vm is equals to root 2 V RMS, hence by VDC becomes 2 into root of 2 V RMS divided by pi. ಸೊ ಆ ವ್ಯಾಲ್ಯೂನ ವಿ ಆರ್ ಎಮ್ ಎಸ್ನ 200ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಇನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂಸ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಒಬ್ಟೈನ್ 180 ವೋಲ್ಟ್. Similarly, average DC voltage, DC current is given by, as per the Ohm's law, IDC is equals to VDC divided by RL. Our values na substitute ಮಾಡಿ simplify ಮಾಡಿದ್ರೆ we are going to obtain 180 milliampere. Similarly, ripple voltage is given by VR is equals to VDC into gamma, and it is calculated, that is for a full wave rectifier it will be 0.48 value will be the ripple factor. Hence if I substitute the value of standard or ideal case value into the VDC, I am going to obtain the ripple voltage as 86.8 volt. Then let us move on to next problem. In a center tapped full wave rectifier, the load resistance is 2 kilo ohm. Each diode has a forward bias of resistance of 10 ohm. The peak value of voltage across a secondary coil is 210 volt. Find peak value, current and RMS value of a current and ripple factor of the above full wave rectifier. For that they had given load resistance as 2000 ohm, and diodes are going to be have a resistance in a forward biased condition as 10 ohm, and maximum voltage is 210 volt. For that a peak value of current is given by Im is equals to Vm divided by RL plus F as per the Ohm's law. Then if I substitute the value of Vm, RL and Rf, I am going to obtain the value as 0.104 milliampere. The next part is RMS value of a current, and it is given by IRMS is equals to I maximum divided by root 2, that is maximum value of a current divided by root 2. Therefore, if I substitute and simplify, I am going to obtain the value as 74.28 milliampere. And third one is average value of DC current. For that, I am going to have a relation as IDC is equals to twice the Im by pi. If I substitute the values of these, I am going to obtain the IDC as 66.24 milliampere. And the last part is ripple factor, and ripple factor is calculated using a formula gamma is equals to root of IRMS divided by IDC whole square minus 1 under the root. If I substitute the value of IRMS and IDC and simplify, I am going to obtain the value as 0.48. The ripple factor of a full wave obtained is going to be 0.48. Similarly, now let us discuss one of the simple problem on the Zener diode. 10 volt Zener diode is used to regulate a voltage across a load resistance. The input voltage varies between 12 volt to 20 volt. The load current varies between 10 to 85 milliampere. The minimum Zener current is 15 milliampere. Then calculate the value of series resistance. Question ನೋಡಿದ ತಕ್ಷಣ ಭಯ ಪಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ತುಂಬ ಸಿಂಪಲ್ ಇದೆ. As we know that Zener diode voltage as Vz is equals to 10 volt, and that is going to be vary is 12 to 20 volt. Then Iz, that is a constant current of 15 ampere, are going to be obtained with the variation of load current as 10 to 85 milliampere. For that, the Zener diode will be conduct with minimum current when input voltage is minimum. Therefore, Rs, the series resistance, must be connected as Rs is equals to Vi minus Vo divided by Iz minus IL. Therefore, if I substitute the value of Vi and Vo, which means the variation of 12 volts to 10 volts, therefore 15 plus 85 milliampere. Finally, after simplification, I am going to obtain the value of 20 ohm resistor are going to be connected in series with the Zener diode. I think you had already discussed, but many of the students were absent, hence I repeated these problems once again. Thank you.